I grew up doing machine interfaces, and that's really been my passion. I like to go out and touch the equipment. I like to be able to create something that interfaces with the machine and causes parts to come out. And you could put me out there and I'll just be happy. I don't need anything else. I just need to go play with the equipment.
Hi, this is Tim Heston, Senior Editor at the Fabricator magazine, and thank you so much for joining us for this in-depth version of Automation Talk, a podcast by FMA, brought to you by Salvagnini America. This edition, we're taking a deep dive into software automation. Specifically, we want to delve into all the implications modern software has on modern precision sheet metal. I've been reporting on this industry since 1998, and during those early days when I visited fab shops, I would see huge batches of parts, and those huge batches meant success. The shop was busy. It was producing large quantities for somebody. That's evolved over the years. Machines have become so fast, changeover has become so quick, so seamless. Work can now flow in smaller batches and even smaller kits, with each different part in that kit being cut and then formed one right after the other. The stumbling block in all this really has been information flow. What information do operators have at the machines? What do engineers and estimators have to work with in the office? The visibility from order to cash has sometimes been lacking in this industry, and software is stepping up to fill that void. Just because software has come a long way over the past few years doesn't mean every fabricator is at the same place or even on the same kind of software journey. Everyone has their own path, but everyone is walking forward, and the digitization of metal fabrication is well underway. And we'll be covering these different paths during this podcast series. The first will be Train Technologies. We'll be covering the company's commercial division, and particularly its innovative approach to software automation. Its precision sheet metal operation pioneered the use of production software, and today they're at the optimization phase. Their Columbia, South Carolina plant uses Salvagnini OPS, or Order Processing System software, that connects directly to the company's internal systems that identify and interpret continually changing demand from downstream processes. The goal is to achieve that optimal workflow through the entire value stream. To get the story, I spoke with Joe Wheatley, CAM engineer at Train. He has a unique background rooted in computers and software, and that all-important human-machine interface. He's been fascinated by the symbiotic relationship between machines and software, and he's spent a career perfecting that relationship. I'll let Joe take it from here. Do you have background in software, or like before you, or was it, did you teach yourself all this over the years?
Well, I have a master's in computer science and engineering math.
Well, there
I
you go.
grew up doing machine interfaces, and that's really been my passion. I like to go out and touch the equipment. I like to be able to create something that interfaces with the machine and causes parts to come out. And you just put me out there and I'll just be happy. I don't need anything else. I just need to go play with the equipment. Well, the Salvagnini equipment has been super fun because the level of automation that we have and things that we've been able to do. We built a system to measure OEE. And so we've sort of pioneered how to measure OEE on the Salvagninis. And they now have some really cool software for measuring the equipment themselves. So we've got a lot of Salvagnini equipment. Purchased OPS with the latest system that we have, and OPS is fully integrated with the machines to deliver nested jobs and provide feedback for completed orders and parts. But the performance and reliability and robustness of OPS UI over the years have significantly evolved, and Salvagnini's done a really good job getting that software to perform the way that we need it in order to meet the needs of our plant and our customer. Well, with only one sheet metal process, we can now send an infinite amount of design variations through fab. The software automation provides a platform for delivering quality products consistently. We've been able to use the automation to drive errors out of the process and keep them out. Our system is flexible enough to provide one piece flow on one job and have a Kanban batch in the next job with no setup in between. OPS does a great job. It can create a single job with multiple materials, and this gives us a real advantage for our sales order kitting for panel fabrication. Every job that I send is a one-time run job. Every part that I send to OPS is program fresh. You know, we had to spend time proving out and getting our data clean and our drawings good and clean. But once we got that, we can just feed it to the system, and it goes into the system and gets programmed, delivered to the machine with a high level of accuracy and very few errors. We inkjet a label on every part, and that was purchased as part of the Salvagnini system. When we configure the job, the XML data that we send to it has all the information that we need for the forming and the inkjetting and the labeling process. So the S4 actually does the inkjet. So we're putting new parts on every day, parts that were just created and just run. And we have to have those reliable so that they'll hit the machine and not create a problem. So we've had to really work on the robustness of our design process to make sure we get clean geometry all the way out to the machine. You have to use all the tools of your toolbox. It's not just the software that we have to really think about. It's also the design. You know, we spent a lot of time working with our design folks and helping them understand what the machine can do and what it can't do, and getting them to make designs that were much more applicable to the S4P4 system. And so you have to work both sides of that coin. Actually all sides. You have to work the design side and the software side, and also the maintenance side to keep it up and running and keep everything fully functional.
The train story has two important takeaways. First is the marriage of part design and manufacturing process optimization. That relationship becomes so important because with software tailored and optimized for certain pieces of equipment, you can see the process down to the machine level. You can see how a panel bender bends versus a press brake, including an actual visualization of how each process takes place. The clamping tools and bending blades on a panel bender, how they manipulate the workpiece to actually create each flange, and the punch, workpiece, and die interaction in a press brake air forming operation. You can see the flange lengths required, the effects of features near bend lines, or where a part manipulator on a panel bender needs to grab and secure the workpiece between bends. You can see slat or grid positions in laser cutting, and the optimization of a punch and shear operation in a flexible manufacturing system. It's all about optimizing these details with part design. And that information, flange length, features in a way of a bend line, and all these details, software brings that all into the limelight. And you're not throwing things over the wall to manufacturing anymore. Jobs are scrutinized on the front end so they flow to the floor with few, if any, surprises. Few surprises also means you can optimize sequencing and scheduling. If things are predictable on the floor, you can really optimize the timing of which jobs hit what work center when. And that's the second major takeaway from Train's story. The less time it takes to fabricate the first part in a batch, the smaller those batches can be, and you can get that operation closer to that single piece part flow ideal, while at the same time balancing the work with all the other jobs on the floor. So it's a complex puzzle, and people can solve it only so much before it goes beyond one's own capability. You just can't juggle that many balls in your head at once. And so software solves more of that puzzle, and in doing so brings metal fabrication to that next level. So what does it really take to get to that next level fabrication? Well, Matt Humerick is a good person to ask. He's CAD/CAM and OPS process engineer for Salvagnini America, and he has a broad swath of experience, both in front of the machine and in software optimization. His career really can be boiled down to focusing on getting software on the same page as the reality experienced on the shop floor. The closer that software can emulate real-world production, the smoother that real-world production can really be. So I'll let Matt take it from here.
I started off at Salvagnini with just doing mechanical installations of our machines. So installing machines, any type of mechanical work. From there, I moved over into the electrical components of the machines, where I would connect systems, FMS systems, large intricate systems. From there, I moved over into our startup and testing department, where I would install, test, startup, train panel benders, punching machines, FMS systems. From there, I moved over into the applications department, where I was responsible for punching time studies, panel bender time studies. So basically, a customer would come and say, here, I have this problem, these parts. How do I make these parts? What do I have to use? I would kind of come up with a solution for them. And then from there, I was handed off the software project when we introduced Stream back in 2017. And since then, I've been doing just software projects as far as our offline programming, but also a software called OPS, which is our automated process of taking an order from an ERP system, generating some production jobs, sending to the machines, and starting in an automatic type of way. So obviously in the software, you want to be able to see what's going to happen on the machine before it arrives at the machine, right? So that's a very big thing. You don't want to send production down to the machine and have to rework because there's some problem. You can simulate the full system inside the office, whether it's the punching side, the blanking, the laser cutting side, the panel bending, the forming side. You want to be able to see everything that's going to happen before you send it to the machine, because time at the machine takes away from production, right? So when you take away from production, you're losing throughput, you're slowing down your profitability at the end of the day. So offline programming has to be accurate, has to be fast, has to be reliable, but also user-friendly. So you don't have to have an expert in all aspects to understand how to make a program. If you can see graphically, you can understand the process much better. So this kind of gives you the ability to use a design for manufacturing thought process in it, to where the person that makes the design, the 3D representation of it, can make a couple of simple clicks, be into the software, and see how it's going to run on a panel bender, for example, right? So they can see if it's a feasible part, if there are some changes that they can make on that actual part to make it run better on the machine. They can look at the 3D of the part and they can say, well, can we redesign this part to put multiple components together, right? So before, obviously, it's always been, you have 4 or 5 components, they go together, maybe they go to welding, and then there's your final assembly, right? With panel bending and the ability for the engineer that designs the part to be able to visually see what's going to happen, it gives them an opportunity to improve the process, improve the output of the machine, and also reduce the secondary operations, whether it's assembly, welding, painting, whatever it might be. They can reduce that time to where the bottleneck is then alleviated as much as possible in those aspects. With the panel bender software, what will happen is you make a model. You make a model for, let's say, a press brake with a specific V-die. Therefore, your radius is going to be some value and your K-factor is going to be some value, right?
Right.
When it goes to a panel bender, the K-factor development on the panel bender is going to be a little bit different versus a press brake, right? So in our panel bender software, what will happen is when it creates a program for the panel bender, it's going to automatically generate a correct developed 2D pattern that you can run on your blanking machine. That way, when you run it on that panel bender, it's going to be exact every time.
It's going to be exact every time. That's the ideal most fabricators strive for. And the idea is to minimize or eliminate rework and those unnecessary secondary operations. This again happens through the marriage of smart part design. Do we need that hardware there or that feature so close to the bend line? Those are basic things, but the details go from there. And manufacturing process optimization is also part of the picture, scrutinizing both material choice, scheduling, sequencing, and a host of other details. The bottom line is that so much today can be determined before an operation reaches the shop floor. And that's what software really is all about, especially when it comes to the precision sheet metal fabrication industry. But again, everyone is on a different software path. So next time, we'll be talking with Custom Metal Contracting, or CMC, an architectural fab shop based in Calgary, Alberta, Canada. They'll be talking about their shop, the work they do, and what their current state of software is, and the journey that they plan to take. So thanks so much for joining us for this episode of Automation Talk, produced by FMA and brought to you by Salvagnini America. And we'll see you next time.